Welcome back to our next unit in trigonometry. In chapter 14 is going to we're going to focus on equations and solving for sides and angles. In this chapter, in the trigonometry aspect, we're going to focus on graphing for the most part and do little proofs and verifying at the end. But a lot of this chapter is graphing. So today our main target is I can graph sine, cosine, and tangent functions in the coordinate plane by hand and with a graphing calculator. Okay, graphing sine and cosine and tangent functions. We're going to start with sine and cosine. We'll get to tangent in a minute here. Sine and cosine functions, if you look at them, they look like waves. They may remind you of radio waves, or even just waves from the ocean or the lake or whatever. But that's what sine and cosine are. They're basically the same type of waves. Just sine and cosine, they kind of have different high and low points. The high and low points kind of alternate. They don't line up exactly. If you compare the cosine and sine, you can see here at sine, it kind of starts at 0, 0, and it goes up and down from there. And you can see at 0, we're up 1 for the cosine and go down. So very similar shapes, and you notice the values repeat. We vary from -1 to +1 and back down for our y outputs. So you can see that on the graph. That's why they're called periodic. Periodic function is a function whose graph has repeating patterns. That's cosine, sine, and we'll exchange in a minute. Cycle is the repeating pattern of a periodic function, and frequency is the number of cycles per unit of time, the reciprocal of the period. So we're going to just kind of describe some general information down here about these functions, and then we'll kind of look at the graph as we go. The domain for both of these is all real numbers. There is no limit on what we can plug in to a trig function, at least the sine and cosine one. That's the tangent a little bit. The range, we just talked about that. They range from -1 to +1. So all your y's are going to be somewhere between a -1 and a +1. The max and the min, same for both. Now this is the parent function. Obviously, when we get more complicated graphs and we have an a value that's not 1, that's going to change it. But for the parent functions, our max and min are 1 and -1. X-intercepts. Okay, well, we can see for sine, it crosses at, looks like multiples of pi. 1 pi, 2 pi, 3 pi. So, looks like it starts at 0, and if we go left or right, so positive or negative pi directions, we're going to hit the x-axis. That is a 1 and on and on. X-intercepts here, well, it looks like we have halfway between 0 and pi. So our x-intercepts for cosine are plus or minus multiples of pi over 2. So pi over 2 plus or minus 3 pi over 2 plus or minus 5 pi over 2. Start at pi over 2 and add pi units to that, and we're going to get 5 x-intercept points for that. Okay, some terminology and some equations for values we're going to calculate for these functions. Amplitude and period. So we're going to add a little bit to this. A and B. A is the kind of coefficient of the whole sine and cosine function. That's going to describe our amplitude. It's 1/2 of the max minus the min. So if you have the maximum and the minimum, you can calculate it that way. Otherwise, just look at the equation for A. The absolute value of A is our amplitude. And excuse me, our max, different max min, and our period is a horizontal length of one cycle of the periodic function. When we start graphing, we're going to just graph over one period. So we have to know how long our period is so that we can divide up our intervals appropriately. And that's 2 pi divided by the absolute value of b, because it's a length. That's why they're absolute value. Same with amplitude, that's a length. That's why it's absolute value. You can't have negatives. Okay? So amplitude, that's the height of the wave, if you will. Okay? So if we had a graph here, and we this look. Here's a nice little sine function. If we want to calculate the amplitude is the distance from the midline, they call it, okay, to the highest point or lowest point, the height of the wave, okay? The period, well, if we look here, it repeats itself from this point to this point. So this distance would be a period. So it's a horizontal distance. How long does it take before you start repeating outputs? Okay, let's graph the sine function. Y equals 2 times the sine of x. Now have your calculator ready because we're going to use that. We're going to depend on that a lot. But I'm going to show you how you can do both and get some nice values using your calculator. The amplitude, well, that's the absolute value of A. A is 2, so the absolute value of 2 is just 2. So as high as 2 and as low as -2 as long as you don't move the graph up and down. Period. 2 pi over the absolute value of B. Well, B in this case, so there's nothing between sine and x, so B is just 1. So 2 pi divided by 1, its absolute value of 1 is just 2 pi. So we're going to repeat every 2 pi units. So here's what I want you to do. We know the period is pi. Okay? To graph this, we have to get some intervals for our domain. So our domain, in other words, our x values in our table. We're going to make an xy table here. Okay, so we're going to start at B. In this case, we're going to start at 0 for these today. Tomorrow it's going to be a little different than the other 6. So we're going to start at 0. But what's our interval going to be? Well, the way you do this is you take your period. This is a formula that's not in your note or in your formula sheet or in your book. Take your period and divide it by 4. That's the formula for finding your intervals, the interval length. Period divided by 4. Our period is 2 pi. We divide that by 4, we get pi over 2. So we are going to add pi over 2 from 0. So we start at 0, then we do 0 plus pi over 2, which is pi over 2. Then we do pi over 2 plus pi over 2, which is 2 pi over 2, or just pi. So then we're going to do pi, or 2 pi over 2, plus pi over 2, because I'm leaving it like that because I want to like good operators. That's 3 pi over 2. And then our last one, 3 pi over 2 plus pi over 2, that's 4 pi over 2, or 2 pi when we simplify it. So, how do we know we did this correctly? Well, we know we did it correctly if we take our big value, if we take our biggest value on the far right and subtract our first value, we should get the period. 2 pi minus 0 is 2 pi. So we have the right value. There should be 5 numbers at the top of your table. Those are the 5 inputs we're going to use to get our 5 outputs. So we can do this by hand, or we can use our calculator. Our mode in this time when we're graphing, last time we were in degrees quite a bit, last chapter. Make sure you go to mode and hit radian. So we're graphing these 9 times out of 10, you're going to be in radian. I'm already highlighted on radian. If you're not, go down to the word radian and hit enter on it so it's highlighted. It may be highlighted on degrees, so if it looks like that, just hit enter on radian and it'll move back over. So we can figure these out one at a time. So 2 times the sine of 0. We get 0. So we're going to plug these in. 2 times the sine of 0 is 0. So that's our first output. Then we're going to do 2 times the sine of pi over 2. What do we get when we do 2 times the sine of pi over 2? 2 times the sine of pi second power t divided by 2. We get 2 as an output. So we're going to do 2 times the sine of pi. I'm just going to delete. See if I already have this in here. All I can just use this to make it go a little faster. We get 0. Make predictions on what the 3 pi over 2 is going to be. I'm going to actually go up here and steal this one because it's already pi over 2. And if I just hit second insert, 3 pi over 2, we said negative 2, do it over. So 2 times the sine of 3 pi over 2. Oops, it is 2 sine of pi already. Sorry about that. I'm going to write it down. And that is negative 2. Any guesses on what the sine of 2 pi is going to be? Or 2 times the sine of pi is going to be? 2 pi. If you said 0, you just might be correct. And it is. It's 0. So 2 times the sine of 2 pi was 0. So we have x, y values. We can plot them now. We're going to go set up 0 to 2 pi. We're going to go as high as positive 2, as low as negative 2. We're just doing one interval, so we're going to plot the points. 0, 0, pi over 2. Here's pi over 2 right here, up 2. We go to pi. Pi's over here. They skip the intervals. They stretch them out a little bit different. That's okay. 0. 3 pi over 2 is negative 2. And then 2 pi is 0. We connect the dots. Remember, we know what these are going to look like. These sine and cosine are going to look like waves. But here they are over one interval. We know it's going to repeat. We put arrows. It's going to keep going. There's graphing it by hand. How would I do this in the graphing calculator? In the graphing calculator, we would go to y equals. We would go to, and we type in 2 times the sine of x. And this is why we need to have our intervals or our measures in radians, not degrees. And we're going to go to our, we already set up our intervals. This is something we do by hand. Setting up the intervals, we have to have that because that's what we know how we want to set our calculator up. So once we do that, we're going to go to our table set, which is second window. We want to start at 0. That's where our table starts. But our changing table, that's going to be different. We want that to be pi over 2. That was our period divided by 4 value. So when I go to graph, and I see the picture, it's going to look like that. Now, I'm also, we also need to go to our regular window, and we can do the same thing, 0, and we're going to go, our max is 2 pi, and our x scale, that's going to be our intervals, that's pi over 2. So we go second table set, make our intervals pi over 2, and in window, make our windows pi over 2. We can make this go from negative 2 to positive 2 as well, like our window. And now let's see what our graph looks like. Now our graph looks very similar to what we have here on the right side. Okay. The reason why I did the second table set, and I did this, I did 0 and pi over 2, is we can also use this to give us our outputs. Notice how I plugged all the outputs in one at a time? They're all lined up for me. But if we look at these numbers, they don't look like 0, pi over 2, pi, 3 pi over 2, and 2 pi. We'll go to your calculator. What is pi over 2? As a decimal. Pi over 2 as a decimal is 1.57, which is what you can see is across from 2. Pi is 3.14. 3 pi divided by 2 is 4.71. So those are just the decimal equivalents. If you've gone through by hand and figured out what they are in terms of pi, then the calculator can do the table for you as well. Okay, y equals 3/2 cosine of pi x. Amplitude and period. So the amplitude, real quick, that's the absolute value of 3/2, which is 3/2. And our period is 2 pi over the absolute value of pi. That's what pi, that's b. This is a. 2 pi over pi is just 2 even. So our period is just 2. So our intervals / domain, remember that formula we looked at in the last slide? That is 2 pi, or period, excuse me, divided by 4. Our period is 2/4, that's just 1/4. So we're going to start at 0 on our table, and we're going to add fourths. 1/4 and 1/4, that's 2/4 or 1/2. 2/4 plus 1/4, that's 3/4. 3/4 plus 4/4, 1/4, that is 4/4 or just 1. I just realized that in going quickly, trying to avoid the bell ringing here, I messed up and 2/4 is 1/2. Let's fix this here. You're probably all at home screaming, no, that's not right, Mr. Billy. So 0 plus 1/2 is 1/2. 1/2 plus 1/2 is 1. So that happens when you go too fast. 1 plus 1/2, that's 3/2. And 3/2 plus 1/2, well, that's 2. That's 4/2 and 2. So those are our inputs. Let's real quickly, let's just set it up in the calculator. Our equation is y equals, let's clear that out, 3/2 times the cosine of pi times x. We want to make our window go from 0, the same interval we have here, 0 to 2 by 0.5 or 1/2. And we can go y min and y max -2 to 2. That'll fit from -1.5 to +1.5. But if we want to just be consistent, -1.5 to +1.5. That's a 3/2. This is our amplitude. When we go to our table set, we're going to start at 0 and we're going to go by 0.5s. So we go to graph, we graph it. Here's what it looks like. And we obviously can graph, that's what our graph should look like. Our outputs though, if we go to second table, and we start at 0, we can just copy this table down into ours, or use it if we want to. 0, 1.5, 1/2, 0, 1, -1.5, 3/2, 1.5, 0, and at 2, 3/2, 0, 2 is 1.5. So we can plot these points, 0, 1.5, and 1/2, 0, 1, -1.5. I gotta change my scale here, don't I? This is 1, and then 1.5. This would be 2. I plot all my points. I have connected with a smooth curve. Here is my trig function. Okay, let's look real quick at tangent. I know this is getting along here in time, but let's do tangent real fast. Y equals a tangent of x. The period's a little bit different form. The pi over the absolute value of b. The domain is all reals except where the asymptotes are. So we're going to keep track of where those asymptotes are. The vertical asymptotes are not part of the graph. The range of this one is all reals. Each of these little pieces of the graph, this is a repeated graph. It looks like cubic functions that repeat. They go up and down forever in all directions. Period x-intercepts. For this one, you can see they intercept the x-axis at 0, and then every pi plus or minus away. So every 0, and then pi either way, either direction. That's what it is for the parent function. The parent function of the period, b is 1, so the period is pi. So that's the parent function, y equals tangent of x. Y equals a tangent b of x. If b changes to something other than 1, then that's going to influence our period as well. Okay, one real quick example here. Once again, we're going to use our graphing calculator. Here's y equals 2 times the tangent of x. So if we're not moving the x-intercept around, I'm going to move this over here. Get myself more room. If we're not moving things around, then the x-intercept is going to be 0, 0. That's where we're going to start. So our vertical asymptotes are going to be x equals pi over 2b and x equals negative pi over 2b. The halfway points, that's the points halfway between the middle, okay, where the graph kind of turns, and the asymptote lines. So we already know that the x-intercept is 0, 0 because we don't have an h or a k yet. We haven't talked about that stuff yet. X equals pi over 2b. So what is our period? First of all, well, our period is pi over b, which is pi over 1 or just pi. Okay, our vertical asymptotes then are x equals pi over 2 times 1, and x equals the opposite of pi over 2 times 1, or just pi over 2 and negative pi over 2. So here's pi over 2 and negative pi over 2. I'm dotting these. These are asymptote lines. Remember, asymptote lines means they're not really part of the graph. They're just barriers. So now we can get halfway points. We can also just use our graph. I'll show you how we're going to do that in a minute. Halfway points, halfway between the asymptote line and the middle. So half of pi over 2b, in essence. That's why we get 4b. So pi over 4 times 1. Our a value is 2. That's one coordinate. And negative pi over 4 times 1. Negative 2 is our other. That's really just pi over 4, 2. And obviously negative pi over 4, negative 2. So we're going to plot all these points here. Pi over 4. So here's pi over 2. Pi over 4 is halfway. Up to 1, 2. Pi, negative pi over 4 down 2, and remember, tangent functions kind of just look like cubic. Okay, and then this pattern is going to repeat. I could translate this, so I'm going to have another, every pi units, I'm going to have another asymptote line. So if I go pi units over here at 3 pi over 2, I could approximate another tangent function. And if I go pi units over here to negative 3 pi over 2, the same thing's going to happen. Another tangent function. Okay? Let's graph this on one interval on our graphing calculator. Let's set it up strategically here. Let's clear this out. 2 times the tangent of x. Okay, so we want our intervals to be between our vertical asymptotes. So that's going to be a little different. In our window, we're going to go from negative pi over 2 to positive pi over 2. We want our intervals to be pi over 4. So that's halfway between 0 and pi over 2. Our y min and our y max, it doesn't really matter all that much. We'll go from negative 5 to positive 5 because those go up forever. Those can go by 1s. If we want to get values to plot, we can do that too. Second window, we're going to start at negative pi divided by 2. And we'll make our intervals go by pi over 4. So first, let's graph it. Let's see what we get. This looks similar to what we have here. Just like it to me. And if we go to the table, if we really want to use our table for the graphs, look at it, it says errors at negative pi over 2 and positive pi over 2. It gives us our halfway points as well. It says error because those are asymptote lines. They're not part of the graph. So sorry that this was a little lengthy one, but we did need to get you all this information. I think we did cover sine, cosine, and tangent functions and how to graph them by hand and with the graphing calculator. You have your notes ready for tomorrow. We'll see you then.